So we're going to take a look now at recursion, and we're just sort of visiting different topics related to functions. And recursion is another topic, another thing that you do with functions. And I just want you to have a little bit of exposure to it so that you have a little bit of familiarity with what recursion is, so as you grow as a programmer, if you come across it, you understand what's happening. I will say that anything you do with recursion, you could also do with a loop. And I favor loops over recursion. I think recursion is unnecessarily complex, and it also can have negative impacts upon memory usage in your program. So I tend to stay away from recursion, but I want you to be aware of what it is if you've never seen it before. If you have seen it, you could probably skip this video. But recursion is when a function calls itself. So the function is calling itself. We've looked at closure, where we're using a function and closing the scope of a variable and returning a function. We've looked at callbacks, where you pass a function into another function and then that function uses it. We've seen how to return a function. We've seen how to assign a function to a variable. We've seen anonymous functions. So we've seen a lot of different things with functions. And now we're going to see recursion. So recursion is a function calling itself a certain number of times and then stopping. And you always have to have some way for your recursive function to stop. So the classic example for illustrating recursion is factorial. And a factorial is where you take an integer, a number, and you multiply it by every integer beneath it down to 1. So if we had 4 factorial, that'd be 4 times 3 times 2 times 1, and that would give us 24. So the easiest way to understand recursion is, first I'm going to write a factorial function that uses recursion to calculate this, and then we'll walk through and analyze what it's doing. Because if you try to analyze it while I'm writing it, it gets a little bit confusing. So first thing is we want to kind of replicate this thing where we do n and then we multiply it by n minus 1, but we need to make that recursive. And so that's what made it recursive right there. In this function factorial, we're going to return n, and then we're going to multiply it by calling factorial again, which will return n minus 1. Well, think about what that does. N, if we call factorial up here, and we'll assign this to some number, and then we call factorial, and we pass in 4, the first time it's going to return 4 multiplied by, and then it's going to do factorial 3, because 4 minus 1 is 3. Well, factorial 3 will be 3, right, multiplied by, and so this is like, right here, the second chunk, that we're getting, and I'm just putting these in. So you can kind of see, right, pass in 4, that calls factorial 3, which means 3 multiplied by 3 minus 1 is 2, and call factorial again, and so it's going to be 2, right? And you can see it gets wonky. And then that's going to be 2 right here, multiplied by 2 minus 1 is factorial 1, so factorial 1 is that 1 right there, and then multiplied by factorial 1 minus 1 is 0. Well, that didn't work. And so now what we need is some condition. So if n is equal to 0, we need to break out of this. And we're going to do return 1. So what happens now, right, is we start off with 4, factorial 4. And so that gives us 4 times, and then we do factorial 4 minus 1, which is 3. So 3 comes in here. Is 3 equal to 0? No. And so we return 3, and then multiplied by, and 3 minus 1 is 2. And so we do factorial 2, and we return 2, multiplied by 2 minus 1 is 1. Is 1 equal to 0? No. So we do 1 right here. That's the 1. Multiplied by 1 minus 1 is 0. And so we come up here and we do 0. Is n equal to 0? True. And that's 1. Right? So that returns 1. And then each of these unwind backwards until finally we return the entire sum from here. So this return does this, and then it has to figure out all of this expression first before it returns that. So it actually unwinds, right? We have times 4 minus 1. This is kind of what it looks like. Times 3 minus 1, times 2 minus 1, times, and then times 1. Okay, so that's what it looks like. So that gives us the 4, This gives us the 3, that gives us the 2, that gives us the 1, and then it gives us here 1 right there. 1 times anything is 1, or is the thing. 1 times anything is the number. So that's how we do that. And these all have to unwind. So those functions all get put into memory, and then they unwind, and we get back from this the value, we get back from this one the value, we get back from this the value. All of the multiplication occurs, and then we return that. And so that's going to be factorial n minus 1 is the key for that. And so now if we run this, boom, and then we print that, we get 24. So that's how you do recursion to calculate a factorial. And the easier way to do it would be to use a loop. To calculate your factorial. And so that would be a good challenge for you if you want to pause this video right now. How could you rewrite this code to use a loop instead of factorial? Pause the video now and try it. All right, so now we're going to create a loop to do factorial, and we'll do func loop fac, and we'll pass in an int, and we'll return an int, and we'll do total is equal 1, and then we'll do a loop, and we'll loop over this for init. So we have n, and then we have some condition, and we could do n is greater than 0, so that'll bring us down to 1, and then n minus minus, right? So we're going to loop over n from 4 down to 3 to whatever, and we'll do total times equal n, and then we'll return total. So 4, and we have no initializer. We do have a condition, and then we have a post, and we're going to take our total and multiply it by n, and then we'll return our total. And so if we pass in 4 here, while 4 is greater than 0, we are going to multiply 4 times total, and then we're going to bring that down, and then that'll be 3 times total, and we'll bring that down. It'll be 2 times total, and bring that down. It'll be 1 times total, and bring that down. And then 0, right, means we drop out, we return the total. So let's run it and see what happens. Loop fact, and pass in 4, and then format.println into format and run, and we got 24 again. So that's kind of cool, and it kind of shows you a different way of using the init, the condition, and the post. I just wanted the condition and the post, and I just left the init empty because I didn't need it. And that's doing a factorial without having to use recursion, which is much more efficient, and if you ask me, much easier to understand. And that's what goes about. It's about, say it with me, ease of programming. Ease of programming. Making it easy, making it readable, making it understandable so other people can look at it and they aren't like, what the heck's going on? You're not trying to prove to somebody how smart you are, how clever you are. If you're programming, man, you got it going on already, right? You figured out some really cool stuff. You've learned to speak the language to program computers. That's awesome. You don't need to prove to anybody how smart you are. Show them, like, the true expert, the true sign of a master is somebody who makes the difficult easy. The true sign of a master is somebody who makes the difficult easy. So show people that you're a master as much as possible, and make things as easy as possible for others too. All right, so that's recursion.